Hello everyone, welcome to the next video on vectors. Today we'll be covering the dot product and later on the cross product. First of all, what is a dot product? Let's say we have two vectors over here, A and B, with A as x1, y1, z1 and B as x2, y2, z2. The definition of the dot product, where we have vector A dot vector B, will be equals to the magnitude of A times the magnitude of B times cosine theta. And theta is just the angle between these two vectors. And one note for the theta. For theta, both these vectors must be pointing outwards, and the theta will just be the angle over here. There's actually another computation of the dot product. When we have x1, y1, z1 and x2, y2, z2, if we have this with dot product with this, what we'll get is x1, x2 plus y1, y2 plus z1, z2. As you can see from over here. In case you're wondering, both of these formula will be in your formula booklet. So let's try this out. What's the dot product of 1, 2, 4 and 0, 4, negative 1? This will be this one, 1 times 0 plus 2 times 4 plus 4 times negative 1, which will get this as 4. Now there are a few properties of the dot product that I want you to know. Now if vectors A and B are perpendicular, this means that vector A dot product with vector B will be equals to 0. Why is this so? If vectors A and B are perpendicular, what we have here is cosine 90 degrees. Because the angle over here will be 90 degrees. This term over here will just be 0. And 0 times anything, even the magnitude of A and magnitude of B, will still give you 0. That's why A dot B will always equals to 0 if A and B are perpendicular. Now I have a few more properties that I want you to note. A dot B plus C, with this bracket over here, we just distribute it properly. We have A dot B plus A dot C. So it's just like your rainbow expansion, but instead of a multiplication sign, we have a dot sign. Same with this, what we get is A dot C plus A dot D, and then plus B dot C plus B dot D. So this is very similar to your rainbow expansion, just instead of a multiplication sign, we have a dot sign. And finally, A dot A will be equals to mod A square. Again, we look at the definition of the dot product. If this is A, then this will be mod A times cosine theta. And for what cosine theta is, if you look here, if we have vector A, and vector A is still the same vector, there is no angle between the vector. So this is just cosine 0 degrees. And cosine 0 degrees, we know this as 1. Hence why A dot A will just be mod A square. Now we'll be moving on to the cross product. This is another type of product between vectors. Over here, if you look at this, what the cross product of vector A and B gets you, instead of getting you a number, this time you will get a vector. You will get a vector n. And this vector n represents the normal vector. What a normal vector is, it's a vector that is perpendicular to the two vectors over here. So if you look here, the vector n is 90 degrees to vector A, and it's also 90 degrees to vector B. There's one formula given in the formula booklet. The magnitude of A cross B will be equals to magnitude of A times the magnitude of B times sine theta. Now let's move on to the computation of the dot product. How do we actually find this normal vector n? Okay, let's say we have x1, y1, z1 cross with x2, y2, z2. I want you to listen to this very carefully. How you compute this cross product? First, you cancel out this, and what you want to do is take y1, z2 minus z1, y2. The next part, I want you to block out this middle part over here, and what you want to do is take negative of x1, z2 plus z1, x2. For the last part, I'll block out the last row and take x1, y2 minus y1, x2. Now let's try this question out. Let's take the cross product of 2, 3, 4 and negative 1, 0, 1. The first step is to block out the first row, and what we should get is 3 times 1 minus 4 times 0. The next step is we block out the second row, and we take negative of 2 times 1 plus 4 times negative 1. And for the final step, I block out the last row, and I'll take 2 times 0 minus 3 times negative 1. After calculating this all out, I should get 3, negative 6, 3. Now let's look at some properties of cross product. A cross B is actually negative of B cross A. This is because we know n as A cross B, but there's actually another normal vector, which is over here. And this vector is negative of this normal vector, or B cross A. Now similar to the dot product, for this, what we do is just distribute the sign. This is just A cross B plus A cross C. This is not just some multiplication, this is again the cross product. You have to take the cross product over here. If you actually switch the places of dot product, A dot B is the same as B dot A. But do not mix the order up. We cannot write this as B cross A because we know that these two are different. And finally for this, we can do the same thing. This distributes very nicely to become a rainbow expansion. A cross C plus A cross D plus B cross C plus B cross D. The final thing we're going to look at is the area of the triangle. So remember when I said the magnitude of A cross B is just the magnitude of A times magnitude of B times sine theta? And remember your area of the triangle formula, which is half AB sine theta, where it looks something like this. Here, the magnitude of vector A just represents this length A over here. And the magnitude of vector B just represents this length B over here, because the magnitude measures the length of the vector. And hence, the area of the triangle would just be half of this. Similarly, the area of the parallelogram over here would just be 2 of these triangles, and hence it's just the magnitude of A cross B. Here's the summary sheet regarding the introduction to vectors, dot product, and cross product. After this, we're going to move to lines and planes. This is where we apply all that we have learnt to something more practical.